Hello everyone, welcome to our channel Mathematics Parshala. This is another problem of CSIR UGC NET June 2023 Mathematical Science. The question ID is 704065 and the question is from real analysis, actually from calculus in RN. See the question first. Define f a function from R4 to R by f x y z w equal to xw minus yz. Then which of the following statements are true? So let us first study one by one the options. See here, the function is defined in this way. So for option 1, what can we do? If we suppose pi 1, pi 2, pi 3, pi 4 are the projection maps. What is the projection map? Defined in usual way that pi 1 at x, y, z, w is defined by x. In similar manner, pi 2 is defined by pi 2 x, y, z, w equal to y, pi 3 x, y, z, w equal to z, and pi 4 x, y, z, w equal to w. So clearly this f can be written in this way: a pi 1 pi 3 minus pi 2 pi 4. I am not writing explicitly that fxyzw equal to pi 1 xyzw into pi 3 or like that, just written in short form. F equal to pi 1 pi 3 minus pi 2 pi 4. So now we know that this pi 1 pi 2 pi 3 pi 4, the projection maps are continuous. So the and also if two functions are continuous, then their product is also continuous, their sum, subtraction, all are continuous. So by this pi 1 pi 3 continuous, so their product is continuous, and pi 2 pi 4 is continuous, their subtraction pi 1 pi 3 minus pi 2 pi 4 is continuous. So f is continuous. So f is continuous here on R4. So option 1 is correct option. Now see, for option 2 we have to first find what is this domain actually. This domain is defined by this, so just apply simple calculation that xy plus if we take any xy zw belongs to u, then this xy zw satisfies these three equations. First is this, the second one is x square plus z square equal to 1, and the third one is y square plus z square equal to 1. So solving these three equations, what we get, just see. Now from here just write w equal to, we can write w equal to minus xy by z. Then putting this w here, we have y square, in this third, this is y square plus w square, y square plus w square equal to 1. So writing w here, we have y square plus x square y square by z square equal to 1. From this we have y square by z square. If we take y square by z square as common, then we get z square plus x square equal to 1, and substituting this x square plus z square equal to 1, we have y square equal to z square. So now we have this one condition. Now now what can we do? Also just squaring this both sides, we have w square equal to x square y square by z square, and also put y square equal to z square, we have x square. So what we get, we have w square equal to x square. This is another condition. And then from these two, if we put here z square equal to y square, then we have x square plus y square equal to 1. Now from this one and this one, just subtracting them, we have x square equal to y square. So now in this situation, we have these three that we have here. We have x square equal to y square equal to z square, and also x square equal to w square. So all these are same. So such x, y, z, w in this domain are satisfying these conditions. And also we have that x square plus y square equal to 1. So putting y square equal to x square, we have 2x square equal to 1, and we have x equal to plus minus 1 by root 2. So all these x, y, z, w are only plus minus root 2. So if we consider this set, just plus minus 1 by root 2, plus minus 1 by root 2, plus minus 1 by root 2, plus minus 1 by root 2. So this set consisting of finite number of elements is actually contains U, because all these elements are not in U. Why? Because if we take here x, y, z, w all are 1 by root 2, then this x, y plus z, w will not be equal to 0, because we need some negative. If we take x, y are 1 by root 2, z is 1 by root 2, and w is minus 1 by root 2, then it will satisfy. So such x, y, z, w in U should satisfy all these three conditions. So to satisfy this condition, this x, y, the sign of this x, y, z, w all cannot be same. So this set is actually equal to this U. This contains actually U. This set actually contains U. So clearly this U is here a finite set. So this domain U subset of R4, we are not writing explicitly the set U. It can be done very easily, but we are not going in details because we don't need that. So this U is actually a finite set. So all such elements of this U are isolated points. So now f is a function. Now f is a function from R4 to R4, and we have to find that f is uniformly continuous on U or not. So when we take f is from R4 to R, so when we take and we are considering this function is uniformly continuous on U or not. So it can be easily proved that f is uniformly continuous on any finite set, because all these points are isolated points. So to prove this, suppose epsilon is any arbitrary positive number, and we take delta is in such way that delta equal to half of minimum mod x minus y, such that xy belongs to U. This xy is actually are elements of U, that means a fourth tuple. So we are writing just xy. So then clearly this delta is greater than 0. This delta is greater than 0. Definitely x not equal to y, because if x equal to y, then it will be 0. So if we take delta which is less than the minimum value of distance of any two distinct points in U, so then clearly if we take x, y belongs to U such that mod x minus y less than delta, then clearly this x must be equal to y by our hypothesis of taking delta. So now we surely have our fx minus fy equal to actually fx minus fx equal to 0 less than epsilon. So if we take any arbitrary epsilon, we can find a delta in such way such that this condition satisfies that mod x minus y less than delta implies mod fx minus fy less than epsilon. So f is uniformly continuous on U. So uh, this is the proof of 2. So if it's uniformly continuous on U, so option 2 is correct option. Now see for option 3, this is very easily we can solve, because when our domain V is such that x, y, z, w satisfying x equal to y and z equal to w, then here our f x, y, z, w becomes just put w equal to z here and y into put x uh, y into z. Z means our w. Okay, so put y equal to x, so this is x, and z, so this is 0. So now clearly f is equal to 0 for all x, y, z, w, like all, say we can write x vector or whatever. So for all x belongs to, no, we need, okay, then write another variable, because when we are using x, y, z, w as real number, we should not write as a member of R4. So this is for all. Say another what we should write, say mm, some u element of R4, so belongs to this V. So now f is constant on this domain V, so clearly f is uniformly continuous there. By simply we can solve as uh, we have done in option 2. So f is uniformly continuous on V, so option 3 is correct option. And also see for option 4, this also can be proved easily, because if we take suppose here that this domain, so simply we can take w equal to minus x and y equal to z equal to 0. So our f becomes x into w, so this is minus x square minus 0. So f equal to minus x square. Now see, all such x, y, z, w will be in this w, because this satisfying x plus y plus z plus w equal to 0. So there is no restriction to take this x. So we can take this x very large. If we take as x tends to infinity, then also all such x, y, z, w will be in this set, and this f will tends to minus infinity. So f is not bounded there, so f is unbounded on w. So option 4 is also correct option. So this is the solution of this question. Option 1, 2, 3, 4 are the correct options. Okay, thanks for